There's a specific set of endpoints in this lab where the frontend is using content length while the backend is ignoring the content length, which is equal to content length 0. So that's why this vulnerability class is called CL for the frontend and .0, so content length 0 for the backend. To find and detect a vulnerability like this, we need to first find an endpoint that ignores the content length. And to do that, there's 3 good candidates. There's a post request to a static file that you can do. You can do a post request to an endpoint that does a server level redirect. Or you can do a post request to an endpoint that triggers a server-side error. In our case in this lab, we're going for the first option here, a post request to a static file. Now, once we've found that endpoint, there's one more thing to keep in mind. If we want to later apply this through the browser, we want to make sure that we edit our request settings so that we can send our attack request and our normal request over the same TCP connection. But to do that, we need to set in our attack request, we need to set the connection header to the value of keep alive. Normally, burp will ignore the connection keep alive header, so you need to go under the request settings and enable HTTP1 connection reuse. And then you also want to add both the attack request and the normal request to the same send group and send them in sequence over the single connection, so over the single TCP connection. So let's see what that looks like in the lab. I'm going to switch to burp and then go to proxy and HTTP history. And I'm going to grab just one of the static files here. There's a few to pick from. I'm going to go for the blog.svg, but you can pick any files under the resources folder. Send it to repeater and switch to repeater. The first thing I want to do is go to the inspector window on the right and downgrade the HTTP protocol to HTTP 1.1. And then I'm going to change this into a post request and show new line characters. I'm just going to issue the post request just to make sure that we get back a 200 OK and that this endpoint isn't rejecting post requests, so it's not safe listing GET requests only. I'm going to delete unnecessary headers. It's not really a requirement to solve the lab, but it makes things a bit easier to follow along. So I'm going to remove anything up from content type and underneath the host header. Next thing I'm going to do is I'm going to go to the request settings here and turn off update content length automatically, because if we send this request, we get back a 200 OK. If I set the content length to 20 and send the request, we can see that the response is taking a long time to get back and it will eventually time out because the front-end server is using content length and is expecting content here. So that means that we have to set the content length to smuggle our requests later on past the front-end server. We need to set that to the real content length. So I'm going to turn this back on. And then let's use the differential responses technique to confirm the vulnerability. So I'm going to rename this tab to attack request. And then in our body here, we want to smuggle a request for something that doesn't exist using HTTP 1.1. We also want to set an xignore x header so that our normal request will be appended right after, so not followed by a new line. Then I'm going to go to the proxy HTTP history and grab the GET request for the front page and then send it to repeater and switch to repeater. So this will become our normal request. So just going to rename this tab as well. And then downgrade the HTTP protocol here on the right under the inspector window to HTTP 1.1 as well, and just send it to make sure that we get back a 200 OK, and we do. So let's go back to the attack request. So one other thing we need to do is ensure that we're using the same TCP connection to send both the attack request and the normal request. So I'm going to add a connection keep alive header. You can see that it's underlined, and that's because by default burp is ignoring this header. So you need to go under the request settings and enable HTTP1 connection reuse. Then I'm going to go up here and add both of them to a tab group. And so the attack request and the normal request, I'll name this client-side desync and create the send group. And then we need to go under the send options here, the group send options, and make sure that we send it as a group in sequence over a single TCP connection. So that checks out, I think. So if I go to the normal request, we have a 200 OK here. So if I send this now over the single connection, we get a 200 OK for our post request to the static file. But then for our normal request, we get a 404 not found, which differs from the 200 OK that we'd normally expect. So that confirms the client-side desync or the CL.0 vulnerability. Now let's use that vulnerability to bypass the security controls on the front end, because if you go to the lab and you try to go to the admin panel, you can see the path/admin is blocked. So that's the front end that is implementing that security control most likely. So what we can try and do is bypass it. So if I go back to burp and then to our attack request, so instead of, let me check the URI path, so it's just /admin. So if I go back to burp and instead of our smuggled request here for a resource that doesn't exist, I'm just going to edit that to /admin and then send it over the same TCP connection again. So our attack request and our normal request. And then for our normal request, we get back a 200 OK. If I render the page, you can see that we have the option to delete the users Wiener and Carlos here. So let's go back to pretty and go to the bottom. We need to delete the user Carlos. So I'm just going to copy this link and then go back to our attack request and replace that URI path here. And then send this group over to single connection again. And if I go to the normal request, we get a 302 found. So that likely means that the delete action was successful. And if I go back to the lab and then go back to the front page, you can see, congratulations, you've solved the lab. I hope this was helpful to you, and thank you for watching.